warahmatullahi wabarakatuh and salam sejahtera. Today we will continue our topic in isentropic efficiency of steady flow devices in compressor or pump. This is the compressor schematic diagram, and this is state 1, which is inlet of compressor, and this is state 2, outlet of compressor. The function of the compressor is to increase pressure as well as temperature. And we know in compressor there is W dot in, power input. So, for the power input, we have to deal with two terms, ideal process and actual process. And the deviation between ideal process and actual process is an isentropic efficiency. So, this is the schematic diagram of enthalpy versus entropy. Okay, the pressure at the inlet will represent as P1 by this line and P2 by this line. So we can see that the pressure will increase from state 1 to state 2. Okay, so if the process is an ideal process, then we can say that entropy 1 is equal to the entropy 2. Okay, and since this is isentropic process, then I said that S is S to S. But if it is an actual process, I can say that the entropy here is S to A. Okay, the work, okay, the definition of work here, Ws is isentropic work, and it can be defined as H2S minus H1, and actual work will be defined as H2A minus H1. So if we can see here, isentropic work is less than actual work. Therefore, we can say that the efficiency of the compressor is isentropic compressor work is divided by actual compressor work, H2S minus H1 over H2A minus H1. Okay, if the substance that enter the compressor is liquid, then we can find enthalpy from the property table. But if the substance that enter the compressor is gas, then we have to modify this equation with Cp T2S minus T1 over Cp T2A minus T1. So this is for compressor. Okay, you have to be very careful between compressor and turbine. Okay, and for compressor, as a reminder, compressor is WA over WS, and compressor is WS over WA. Please don't get confused. Next, we go to the isentropic efficiency of a nozzle. This is the schematic diagram of the nozzle, and this is the diagram of enthalpy versus entropy. So if we can see here, this is, and we know that the pressure, okay, will decrease if the liquid or air going through the nozzle. Okay, because the velocity here is low, pressure is high. This is pressure is high and velocity is high and pressure is low. Therefore, okay, this is P1 and this is P2. So this is the isentropic work, okay, given by V2S square over 2, and this is actual process given by V2A square over 2. So we can see here that the actual work is less compared to the isentropic work. Therefore, we have this formula V2A square over V2S square. That's all for isentropic efficiency. Thank you.